Hello guys and welcome to today's video. Right guys, in today's video we are going to be looking at quadratic simultaneous equations actually. So it's GCSE like higher tier for AQA, EdXL, OCR or WJEC. Okay, so we are looking at grade 8 and 9 for GCSE like level maths, AA star. And it's also obviously aimed at like AS like level maths as well. Okay, so we're looking at two examples for today's lesson guys. Right guys, okay, so um so example one, guys. Okay, so x squared plus y squared is equal to 17. X plus y is equal to 3. Okay, so I want to solve this circle, okay, and a linear graph. Okay, so I want to see where it intersects with each other. Okay, so solving simultaneous equations obviously means it tells us where the graph, where the lines, and curve or graph cross with like one another actually. So that's the whole principle of solving like simultaneous equations. Okay, so this one we are looking at quadratic. So solve x squared plus y squared equals 17. X plus y is equal to 3. Okay, so what I've done, guys, is I've rearranged here the second equation. So it's y is equal to 3 minus x. Okay, so then I've subbed in y is equal to 3 minus x into equation 1. So wherever I've had a y, I've replaced it with an x. Okay, and then that will give me an equation that has just x's in. So I'm going to have x squared plus 3 brackets x plus 3 minus x whole squared. Is equal to 17. Okay, so that follows, guys, that I'm going to have x squared plus 3 brackets 3 minus x is equal to 17. Expand my brackets so I get x squared plus 9 minus 3x plus x squared is equal to 17. I would then rearrange it, so so I have x squared plus x squared actually gives me 2x squared, minus 3x is minus 6x, plus 9 is equal to 17. Okay, remember guys that we want quadratics to always equal to 0. So remember, it's always ax squared plus bx plus c is equal to 0. So it's going to be 2x squared minus 6x minus 8 equals 0, which then becomes 2 brackets x squared minus 3x minus 4. So I factored out the 2. Okay, and then I factorize that into 2 brackets x minus 4, x plus 1 is equal to 0. So remember that is factorizing quadratics, guys. Okay, remember that it's two numbers that add to make minus 3 and times to make minus 4. So it's going to be minus 4 plus 1. Minus 4 plus 1 gives me minus 3. Minus 4 times positive 1 gives me minus 4. Okay, so that's how I'll work out that one. Okay, right guys, okay, so then solving this here, I get either x minus 4 equals 0 or x plus 1 equals 0. So the x's are x equals 4 or x equals minus 1 are my solutions for the x, okay? I would then substitute, okay, each of the x ones to work out my corresponding y value, okay? So I'll sub in x equals 4 into equation 1, okay? So it'd be 3 minus 4, which is going to be minus 1 for y. And then x is minus 1, actually, it'd be 3 minus 1, which is going to be positive 4. So my coordinates of intersection here are 4 minus 1 and minus 1, 4. So that would be the points here at which it crosses each other actually. So that's the 2 points where the line crosses the circle, okay, at that point actually. So remember, a circle is in the form x squared plus y squared is equal to r squared. Okay, if you're interested, the radius actually, it will be equal to actually root 17 for that equation. Okay, and then obviously that's obviously straight line graph actually. So y is equal to 3 minus x, so it's got a gradient of minus 1 and it crosses at positive 3. Okay, so okay, so it will cross here at these 2 points. Okay, so that's where the line crosses the circle at these 2 points. Okay, so that's my first example, guys. Okay, for quadratic simultaneous equations. Okay, right, guys. Okay, so example number 2, guys. Right, quadratic and linear. Okay, so we're going to solve actually x squared plus 3x minus 5 is equal to 0, and then y is equal to minus x plus 7. Okay, so we have a quadratic and we have like a straight line graph. Okay, so this time we don't have to sub in. sub it in actually, because y is equal to both actually, yeah. So if I have y equals actually, the rule here is that I would actually equate both equations, because that would tell me where it crosses on the where they actually like interact like with like one another actually. Okay, so I've got x squared here plus 3x minus 5 is equal to minus x plus 7. So all I've done, guys, is just equate this with this. So y is it will be the same at these 2 points, okay? So plus x minus 7, okay, so I'm going to get x squared plus 4x minus 12 is equal to 0. Okay, so remember that we always want quadratics to be equal to 0. Okay, so we then solve this, so it's two numbers that add to make plus 4 and two numbers that multiply to make minus 12. So it's going to be plus 6 and minus 2. So either x plus 6 is equal to 0 or x minus 2 equals 0. So x equals minus 6 or x equals plus 2. So they're my two x coordinates, okay? I would then substitute this into my equation here to work out my value for y. So sub that in, x equals minus 6, so it'd be minus 6 plus 7, so it'd be positive 6 plus 7, which would give me 13. Okay, and then sub in x equals 2 into equation 2, y is equal to minus 2 plus 7, which is going to be 5. Okay, because we know that x is 2, so minus 2 plus 7 gives me 5. Okay, so my solutions to this, it will be minus 6 and 13, and then 2 and 5. Okay, so they would be the coordinates at where the graph intersects here with the line. Okay, so that's how I would work out that one, guys. Okay, so I hope, I hope that actually made sense, guys. So it's two examples here. Obviously, one looking at a circle and a line, and then one looking at quadratic and a line. Yeah. So remember, if both equations here is y equals, I would just equate it. If it's not in the if they are not in the form of y equals, then I have to rearrange one of them and sub it into the other. Okay, so like an example one, guys. Okay, right, guys. Last few points here, obviously that I wrote here actually. Okay, so quadratic equations actually, so they might not always be factorizable actually. So what that means is I might have to use the quadratic formula actually. Okay, to actually solve my equations, okay? So they will not always be factorizable actually. And then sometimes they might not have like real solutions actually, real solutions, which means that they do not intersect here with like one another actually. So you will not usually be given this actually, but sometimes they might throw on the exam actually and then say to you, show that these two do not intersect actually. So you will have to show that the equations do not have like any real roots. Okay, so sometimes they're not always factorizable. Okay, so you might have to use completing the square method or the quadratic formula. Okay, to actually solve your equations, guys. Okay, so I hope that was actually clear, guys. Okay, so I hope that actually was clear actually, and it made sense. Okay, thank you for watching, guys. Please do like my videos actually. Subscribe to my channel if you're new. Okay, and enable notifications actually, so you can be notified that my videos obviously come out regularly. I will try my best obviously to put like a video out every day actually until everything goes back to normal. Okay, so my next video, guys, actually I'll be looking at circumference of a circle and area of a circle. Okay, but feel free to comment below actually if you've got any topics that you'd like me to cover. Okay, and I'll be happy to do it. Okay, so thank you for watching, guys. Please do subscribe. If you can. Okay, thank you for watching, and I hope everyone's staying well and staying safe. Thank you for watching, guys. Okay, take care, and I'll speak to you soon. Bye now.